Hello guys, welcome to the Rustic Wires channel. And this session is about the progress I have made on bringing up the Hi-Fi 1 revision B board with the Rust code. And I'm sure that there would be a lot more work on this, so I have just started with the first part. So this is part one, or the which covers the work I have done till now on the board. So, as this name suggests, this is about bringing Rust code on a bare metal RISC-V target, which means that the target do not have any operating system on it, but the tool chain for that target is available, which means that you are able to write a Rust code and compile for the target, and there may not be any operating system running on it. So how to bring up a hardware on that stage? Okay, so the RISC-V target which I have chosen is Hi-Fi 1 revision B board, which has a core of RV32I AC. If you are new to RISC-V, then please watch the channel which I have linked with this channel, which is named Learn RISC-V. So this RV32IM AC target means that this is a core which supports base 32 integer instruction sets and additional multiply, atomic, and compression instruction sets. Okay, so this is part one, and so far, and this covers the work so far I have progressed on the board. Okay, so five critical things I did to bring up Rust on the bare metal on this target. Okay, so first, can't use standard crate. So in Rust, they don't call that as a standard library. Each module or library is called a crate. And if you are not familiar with the term crate, and this wooden structure is called a crate in the cargo. So those packages are all packed and kept inside this wooden box, and this is what is called a crate. And in Rust world, they use the same terminology to call a library or a package. So the standard library or the standard crate in Rust is a very handy and powerful, and it has got a lot of modules already implemented in Rust. And unlike C, the Rust standard library would be linked by default, whereas in C you would include the standard library. So if you remember the example which I used in the previous video where I compare the type of in C versus that type command in Rust, and this is exactly part of the code. And if you see the file, so you don't see the inclusion of standard library explicitly, but that's included by default. That's why the code is able to use this print line and a lot other functionalities. Okay, so getting back to this, so on a bare metal target, why standard crates can't be included or used is that because so this standard crate is a standard library is very powerful, and it has a lot of functionalities which would heavily uh, depend on the operating system concepts like the memory manager, and it would use a lot of dynamic memory allocations and so and so, and those wouldn't be ready, or those cannot be used when you don't have an operating system yet. So the standard crate cannot be used, and in Rust, you exclude the standard library by explicitly mentioning no std qualifier, okay? Then the alternative to standard crate is the freestanding core crate, which is very simple and it would be architecture specific. It would just have a limited architecture specific functionalities we would see, though we are not going to extensively see what's the difference between the standard crate and a core crate, but we would see what few of the functionalities available in the core crate, okay? So the second critical point is that the entry point. So if there is an operating system, then the operating system would boot up and this Rust code, whatever we write, would be launched as one of a task with the entry point as main. Whereas when there is no operating system, then Rust mandates that you have a start entry point, and Rust should be able to call this and start executing from there. And if you are not aware of this exclamation mark in the function declaration, so this definition, so this is public because this has to be called from external files, and this is a function keyword, and this returns exclamation, and then you have your function body within this curly braces. So this exclamation specifies that this function don't return. For example, when you have a infinite loop inside this, and then if you uh, have an exclamation mark here, and then the compiler would know that this function would not return, okay? And the compiler treats this function differently. And this no mangle, yeah, because this would tell the compiler to preserve the function name so that the overloading or compiler don't change the names because the entry point name has to be preserved. And the third uh, point is that Rust mandates a panic handler function. So if the standard library would have been included, the standard library has its own or has a default panic handling function. But when there is no standard library, then how your panic should be treated should be exclusively mentioned to the Rust with the attribute hash panic handler, and this is the panic handling function. And right now I just have the infinite loop. Whenever a panic occurs in my code, then the Rust would map this function and the execution would jump here and it would loop here, and we can find that, okay, there is something is wrong with the code. And as I said before, if you see here, there's panic info. So the panic module is part of the core crate, and we are deriving this declaration, okay? And more importantly, so the stack pointer has to be initialized so that any future use of stack and stack pointer don't corrupt any of your code or data memory. The stack pointer value would be derived from the linker file. And in Rust, we use the address of the, or not just in Rust, even in C, if you want to derive a value of a variable from the linker file, you would choose ampersand because linker file is all about memory addresses. And we just declare a local variable to get those or to observe the value from the linker file, which is nothing but the stack pointer or the stack start would generally point to the start address after the code and data section, whichever is used by the code, and so that the stack pointer can use rest of the memory for stack operations. And this is an assembly construct as per the Rust programming language that any, so like C, Rust also allows inline assembly code, provided that those are inside this unsafe block, which makes sense because the moment there is a block of assembly code, then the compiler would not cannot keep track of what are all the registers that it has used, and there is no guarantee that the registers used by the compiler is also used by the developer when this assembly code is written, and there's always a chance that these registers can be overwritten and so on. So that's why whenever there is an inline assembly construct, that has to be put inside an unsafe block, and we will see more on this assembly construct in the next slide. So this is the uh, assembly construct which we used in the previous slide. So this assembly construct is part of the core crate, and to use this assembly construct, you just mention use core arc and ASM. And just a brief description on this assembly construct. I'm not gonna go in deep. So this is the uh, construct, and there are two ways. Either you can mention that as an global scope or an function scope. And this is a assembly instruction of RISC-V. It's a which would be like move stack pointer, and you mention another register. So whatever the register you mention here would be moved, or whatever the value you pass here would be moved into the stack pointer. So SP is an ABA name for ABA name in uh, of ABA name of RISC-V. So this construct goes like this. So you have a placeholder, okay, and whatever the value that's given here. So for example, this construct takes an in operand. This can be in or out. Here it is an in operand, and in through which register this construct should take. And in RISC-V or RV32I, there are 32 registers. Either you can mention like x0, x1, x0 to x31, or you can register one of those, you can mention one of those registers, register exclusively, or you can let compiler to choose one from the register class. So here rich means it would just choose one from the register class. And this SP1 is the value. If you go to the previous slide, you can see here the SP1 is the local variable which has the start address of the stack pointer. So this construct would just use this value and load it into one of the register, and those register will be mentioned in this placeholder, and that will be assigned to SP with this move SP command or SP instruction. Okay, and the final point is the trap handler. So before uh, any code or anything is developed, whenever there is an trap, so in RISC-V terminology, trap covers both asynchronous uh, interrupts and synchronous exceptions. So there is a CSR register called MTVEC, or the which should be provided with that trap handler function. And right now I just have a trap handler function which would just loop infinitely, and I can enhance later in future. And if you haven't watched the previous video where I compare the function pointer declaration in C versus Rust, then I highly recommend you to watch the suggested video above, because that would cover what exactly this does. And then this assembly construct would assign the address of the trap handler to the empty vec CSR register. And if you are new to the RISC-V CSRs, which stands for control and status registers, read and write instructions, please watch those videos in the linked channel, which is a Learn RISC-V. Okay, so these are the 5 to comprehend. So the changes, what I have done are that I have added a config file in Cargo to set the build options, because though my host machine is Mac, I need that tool chains for a RISC-V, so you need to cross compile. And I have also written my own linker file, which is a very basic file. Then, as I mentioned before, has to exclude the standard library and use the freestanding core library, and then add the start function, trap handler, panic handler, and set the stack pointer. Okay, and I have already made this changes and published as a crate. If you see first on RV32I. So this is the crate, and you can go to the repository and the source. Whatever I have mentioned, so those files are those functions, the start, trap handler, panic handler, you can see all this, and I would be committing more changes and developing on top of that. And the linker file should be here as well. Let me see here. This is the linker file, and the entry point is start, and the stack start. Yeah, this is a variable. So this dot, that means that after the code and data, wherever the whatever the memory address after loading this text and data, that would be assigned to this stack underscore start variable. That is what I'm using to set the stack pointer. Okay, and if you, so this is a crate, and I already see that I just committed maybe a day or two before, and I see that there are already 35 downloads on this. So that's it, and see you in the next video or next session. Okay, thank you.